Hello, everyone. My name's Eddie Bender. Um, Anna, do you want to introduce yourself and your shop?
Yep, my name is Anand Pandey.
My name is Rishabh Sharma.
And our group is using uh, machine learning to predict insulin usage. So for our project, we used a data set from Kaggle. This data set mainly revolved around um, A1C blood results and predicting whether people would be readmitted into hospitals based on the results from their A1C blood test. As for what A1C is, it is a blood test that measures the average blood sugar level over the past 2 to 3 months. The recommended A1C level is less than 7%, and A1C can be used to diagnose many things, one of those things being diabetes. On it, if you want to go ahead and go to the data set, I'll go ahead and describe it a little bit more. So here we see the data set that we used. It has a lot of things such as patient number, race, gender, age, weight. We'll get more into what we cleaned up, but mainly we cleaned up things that were not used, one, for our prediction model, and then two, there's a lot of these that just don't have values at all. Here we see some medicines that are commonly used to treat diabetes if you want to keep scrolling. There we see insulin usage if they're using it, if they're not using it, up, down, steady. Um, and then there we see whether they're on diabetes medication, yes or no, and readmitted, yes or no, and then greater than 30 days, and there's some other results there as well. Um, this data set was actually taken from the HealthFacts database, um, and it was trimmed down a lot due to um, there just not being a lot of consistency within the data. Let's go ahead and go back here. So with that, we came up with a research question. Are people under the age of 50 more likely to be on insulin compared to those over the age of 50?
For some background knowledge, those that use insulin have type 1 diabetes as their bodies cannot produce insulin. Type 1 diabetes is a type of diabetes which is a genetic disease, and children can have it as often as older people. Whereas type 2 diabetes is formed of a bad habits and diets over a course of many years. Our prediction was that this is why we believe that there will be more people under the age of 50 more likely to use insulin compared to those over the age of 50.
And I will begin our demo. Um, we did the whole abstract thing stuff, whatever. But first off, I started with listing all the columns in the table. There's a whole lot, 50 plus, and I just started removing ones that we don't need. A whole bunch of ID stuff, some diagnosis stuff. Weight was one that we didn't want to remove, but the data collected was terrible, so we had to remove it as well. After removing that, the table has become a lot smaller, but still not cleaned. Another thing was the age. The age showed a range, so I took the lower end of the range, and if the range was 0 to 10, instead of taking 0, take 10. That's one thing. And then there were a whole bunch of columns that are diagnosis columns or like values columns that are measured simply by no, steady, up or down. So to make it better for the model, I we switched it out from 0 representing a no and then 1 for everything else representing that you do have that diagnosis or condition within that relates to diabetes or whatnot. After not renaming, modifying those columns and switching their types, we were ready to actually use that data for data collection. And then, based on our uh, hypothesis that people under the age of 50 are more likely to be on insulin, we have our first bar chart here, which is just shows the count. But with the count, it is a bit hard to show our hypothesis as we predicted. So we made another one looking into it. Um, if you sort of eyeball it, you could argue, but by looking at the proportion of this, you can get a clear view on it. And we just modified the data a little bit better for the proportion, added labels to it, and here's the proportion data. And yellow represents yes, people on insulin, and you could clearly see here that the people under 50 are more likely to be on insulin. It's almost right a bit, just a bit above 40. So the other 60, 59% are on insulin, whereas the other group above 50 is just slightly close to the 50. So that does support our hypothesis. And then we move on to the machine learning model. Rishabh?
So to support our hypothesis that people under the 50 are more likely to be on insulin, we created a model based on various features such as age, gender, and other factors. So we used the data that Anand cleaned up there, and for the first step, we did one hot encoding, so we can use it in the model. And then we set the X as insulin, and we decided to use a random forest classifier because it best fit our needs, and it was good for the amount of data we had. And as you can go down, you can see we trained and active down. Hello.
Yeah, I hear you.
Um, as you can see, um, we got an accuracy of 81%, which was really good. And so based on our uh, conclusions and our research question, we can see that yeah, thank you.
Yeah, one thing I would also like to state about this data set is that all of the people within this data set have either type 1 or type 2 diabetes. This is not just a general data set of everybody that came into a hospital. So when we say they're uh, more likely to use insulin, we mean this because um, everybody in this data set had diabetes. So we're really kind of looking at type 1 versus type 2. Um, you could also look at it that way.
Yep.
And
Yep.
that is it for us. Thank you.
References. Thank you.